today we talk about these two applications, this Strava and Waze. Have you ever used any of them? Never. How about the Joensuu?
I use Strava.
You used Strava. Okay. Never used Waze.
A little, but it's not like usual skill.
Mm-hmm. So, have you used any other sports trackers or navigation software? No. Okay, this is going to be a short lesson. Yeah, so the reason why I want to study these is because they are doing different things. They are location-based applications that are doing different things, and there's not that much to talk about them, so that's why I grouped them together in today's lecture. I wanted to have in this course discussions about different location-based applications that are popular, that have many users, and these ones have like a million of users at least, so that makes them popular in my book. And also, idea would be to somehow speculate what made them popular and why were they a success and so on. So this Strava application, it's meant to be used on many different devices. You can use it on mobile phone to use the GPS sensor, but I believe that there are also some ways to use it on even smaller devices like watches. And you can use it also as on a website. So they have all these kind of different interfaces that that can be used to access your data. It's a sports tracker, so when you start tracking, it's going to begin to record your location every few seconds, 2 to 4 seconds or so. And you will stop tracking at some point from your device when you decide to complete it. And then you will have some kind of collection that is growing. I would like to actually try to log into mine to get a better feel of how a collection looks like. But then again, I don't have a very big collection, so if you see here, I have these kind of only 7 activities. Well, I have a follower. I don't use Strava. I don't use it, but I tested it for my thesis. In my thesis, I did some kind of comparison with other sports tracking software and some of our methods. So I ended up adding here different trajectories. And you can see that I can give a name for these trajectories. The date of recording is also here. And if I click on it, also a little bit more properties, I can edit and delete it. But if I open one example from here, I can see it on the map, similar to how Mopsy was showing trajectories. Down we have some kind of elevation profile, but here you start to see some interesting things that were not in Mopsy, for example. And here some kind of words like top results or yeah, I'm not sure what happens if I click some of these. Okay, it selects part of this trajectory there. So this one has now the name how did I? second. Okay, so this Pöllölampi climb. So this particular part of the trajectory, this segment over here, has a name. This is what they in Strava call segments. And on this particular segment only, so only here, I have a listing here, but oh, okay, I clicked on something by mistake. So apparently on that particular section there I have second fastest time or something like that. According to this interface, it's a little bit confusing because here after I press this I see much more times and I'm very, very slow. I'm like 100 something. I think it means my second fastest climb. So I probably have done that before in the database, and this I was not as good as some other time. But anyway, you can see that I'm like 111 there, 111. But if I go and see some kind of other segment, like now I try this middle one. Okay, here I'm 112. Anyway, so I believe that what they achieve here is that they give you the chance to be better at more things, to be good at more things. So it has these different kinds of scoring lists. And if, for example, I know that I can't beat these guys, I probably know that. I mean, they have times that are twice as fast as mine, so I would need to really, really struggle. But maybe I can be better at one specific small section, like 1 kilometer, really go very, very, very fast. And maybe I'm going to be higher up in the rankings. So what this means is, it means that people may have added motivation to use the system and to go out and to exercise. So they get an extra reason to go out, exercise, and at the same time use the app. So this system isn't available in, for example, Runtastic or Sports Tracker, at least not the versions I tested a couple of years ago. And I believe this is what made Strava to climb like order of magnitude more users than the other applications. More or less just giving you more statistics and somehow more chances to be good at something, which correlates with people's usage of the app. Okay. Then I have to also mention that I have seen some bugs in Strava. For example, I have uploaded here some really, really long trajectory. And with this very long trajectory, these statistics here don't show at all. So apparently it has some bug. I don't know if the bug is caused by them, or maybe they rely on some third-party API for drawing these charts. But for some reason the chart doesn't initialize if the trajectory is very, very long. Now, I don't say that Strava is bad because this happens, because in general trajectories are not so long. So I just tested the system to see that. But I think it's important to know that even these guys that are very, very high somewhere don't have everything perfect. So sometimes sometimes these problems can appear. And here you can also see these kind of different segments emphasized. And I think this may be also some kind of bug, because I cannot be 6 here. 6 was this UC guy. So before this was increasing, and here you can notice this gap. But after that, the numbers should go much higher. Maybe view full leaderboard. Oh, okay. Well, I was not 6, so that there was some kind of bug in the interface as well, but very minor things, like you could see the real number if you click on this leaderboard. And this particular segment, or part of the big route, this activates now, so this seems to work. Yeah, so that's it more or less. Also these kind of social things here, like you can compare with other people, different segments. You can compare with your friends. Motivating each other is also something. But of course, comparison with yourself is also something. So, of course, if you do a specific route and then you are very happy with the result, like if it's a good day, a very good day, it's probably going to be a very hard thing to beat. And that will mean that your next day and next week and so on, all of them will be like failures. They will just go worse because you just happen to have a good day. But if you're going to have like just a small particular part of it that is better, that's what this application tries to figure out. So even though it was bad, maybe this portion here was a little better. So then you start to feel a little better about yourself. So it looks like just that it's more or less a sports tracking app, but it plays with people's minds and with people's it's psychology more or less. So I think that's one of the reasons why it's probably still the best sports tracker nowadays, if you count the number of users, of course. Okay, but let's move on now to or one more thing that is quite interesting here. I think I mentioned also before, but this word here, that word athlete there, it's a small thing. It's just a small decision to use the word athlete instead of user or person. Or Strava originally started for cyclists, so cyclist, but they use athlete. And when they use athlete, it's not the same. I mean, me as a very non-athlete guy, being called an athlete by the application has some kind of effect on me. It makes me feel better. I believe so. It's different than just saying their username or whatever. So small things like that, I think you should consider if you make an application someday. Try to make the users feel important. And small things like this that take nothing to implement can actually be the reason that make a huge difference. So keep an eye out for things like that. Okay, now Who can tell me what this code does? A slight shift from the funny trajectories there, but so this is what is Dijkstra's algorithm known for doing.
Shortest path approach.
Shortest path, okay. Yeah. So Dijkstra's algorithm is an algorithm for calculating shortest path between 2 points in a graph. So this is now arbitrary graph, this kind of very abstract graph. But it's the same algorithm being used in road networks. So if you want to consider the road network, like this is now a map, a Google map, but the road network looks like that. So if I would visualize it, it looks like that. And if you want to know how long, for example, this particular segment here is, it has the same length as that street has between the intersections in the real world. So actually, to be very thorough in the definition, Dijkstra's algorithm optimizes something, optimizes whatever your objective cost is going to be. The simplest thing is to optimize distance, but it can be time, for example, as well. So instead of getting shortest path, you would get fastest path. And this has an effect because sometimes you can go a longer path that is faster because you maybe are allowed to go faster on a highway than on some shorter area. This happens very often in orienteering when people choose to go through the deep forest, but if you stick to some bigger road, even though it's longer, you may be faster than the guys who take the straight path through the forest, because it's just more difficult to go there. So here, this example, the objective function correlates with the terrain difficulty. So in applications like Waze, they do have this kind of network somewhere in their database. And they use Dijkstra's algorithm, but not exactly only that, because Dijkstra's algorithm is not very fast. It's, I believe, quadratic in terms of the number of nodes. So if you would think how large the road network is in the world. So this is just Joensuu city center. But you want your application to give you directions even if you go from here to, I don't know, Germany. So in that case, this graph becomes really, really big. And Dijkstra's algorithm alone would take very much time because it needs to consider all the intersections, all the streets that you will be, all the roads that you are going on. So in practice, if you look to see in OSRM how the routing is done, because it's an open source system, it does use Dijkstra's algorithm, but it also uses something on top of that. And these vary. There are parameters. You can select which method you want to use. One of them is called contraction hierarchies. Another one is called multi-level Dijkstra. So this is somewhat easier to understand. It just means that if you zoom from here, if you zoom out from here, you will start to see all of Joensuu as just one node. So these streets just start to merge into one particular node. So if you zoom out, each city becomes a node, and then the travel distance from the cities become one single link. So more or less the way this system works is that it figures out that to go from Joensuu to Germany, you maybe have to go Joensuu-Helsinki first, then Helsinki, I don't know, Estonia, Netherlands, and or something. I don't think it's connected to Netherlands, but Poland, I guess, is on the way. Anyway, so the path goes to maybe, let's say, 6 of these nodes, and it rules out, for example, that you maybe you need to go from here to Sweden, let's say, because it's just not a choice in this higher level definition of the network. So then when ruling out parts of the network, it starts to focus more in detail. So what are the cities in between Joensuu and Helsinki, for instance? But eventually it does go to the deepest level, but only for the part of the graph that is important. So then the computation time goes really, the efficiency goes really up. So you can get directions from here to Germany, for instance, in a matter of seconds. Now, let's say in this case that you want to get directions from your home here to work, or let's say it's almost time to go home, so directions from work to home. And maybe they would look something like this if you use Dijkstra's algorithm on this particular graph. It's probably the shortest path. I think this one is slightly longer, or maybe here like that. But it's probably longer, so that will not be the response from Dijkstra's algorithm. Dijkstra's algorithm is going to say this one. It's an algorithm that provides the optimum. So it's not an approximation algorithm, it's not a greedy algorithm. It's an optimum algorithm for the shortest path. But the thing is, this is the shortest path in terms of distance, but what happens usually is that if you consider city center, it has many traffic lights or many people there. So when people cross the road, your time is going to increase. Even though it maybe looks like the shortest, you will probably spend more time on this shortest path, but also more gas even, because cars tend to work like that. When you stop, start, it may use even more gas than if you would go, for example, like that, but constantly move, and there would be no traffic lights, and maybe not even people, even because there are less intersections along the way. So the thing is, to do this, your road network needs to contain more information, more contextual information than just how long the segments are. So this is not enough. You would need to know speed restrictions. You would need to know if there are, for example, traffic lights along the way. But Waze does something even better than that. It uses crowdsourcing. So that means that there are people that are using this application everywhere. And if somebody says that, hey, I am here and this is very slow, you maybe know to avoid that place. Or even better, Dijkstra's algorithm uses this information and recommends to you, hey, avoid this place because this other person said that it's going to be very slow that way. So if you open, for example, the Waze website, okay, they have Finnish version, but I'm gonna remove this because some people don't know Finnish, including myself. I know it just a little. Okay, the website is different than I remember it, but they have this live map here. Let's see if it works. It's quite empty. So this is Kuopio now. Oh, well, there was something on the map. There are some markers, but this is a little bit buggy, so doesn't seem to. Doesn't seem to work very well. I guess this is more or less not their priority, and the priority is to work on the mobile good, so this kind of App Store download or Google Play. I think this map is just to see somehow some of the people that are using the application. But it's surprising that actually there are a few that are using it in Kuopio as well. Even though their target audience is bigger cities, it's places where you do have very much of these traffic jams or slowdown regions, for example. So I can't seem to interact with this map very well, but okay, I can click on these red lines here. So somebody updated that this segment has an average speed of 10 kilometers per hour. So this is like running speed. So people that are stuck on traffic, they can press some button there and report there is a hazard here, there is a danger, there is a slow section or whatever. And the other people can see this, but also the algorithms can consider it and give you a better routing system. Now in Helsinki, yeah, you have some kind of information, but most likely the bigger the city, the more of these things are. So it is a widely used application. And in many countries, for example in Romania, some funny things are happening nowadays. One thing what you can do is report when there is a speed camera or some police on the road with this application. So you can say, okay, here there is police people. And the funny thing is that, not really funny, but some people use this to avoid the law. Like they go faster than normal in some places, and then when they see that, okay, some police person is approaching, they slow down. Of course, this is not nice, but they do. And the funny thing, and this is actually funny, is that police also use the app. So police also use the app, and they put fake police in some other places, and then they go hide in somewhere else and try to trick the users. Now, one thing that is very interesting about this, I found it very interesting a couple of years ago at a conference, was that some people are very unhappy about this software, about this Waze software. Could you think of any reason why they maybe don't like that Waze exists? do you think it's a good software? Like, yeah. I mean, yeah, it shows you the faster way to go places because it avoids traffic and things like that. I also thought the same, like, what can be wrong about it? I would not have thought about it, but there is a big community of people who hate it. Anybody in the audience who thinks they know the answer? So who maybe doesn't like this, that this application exists? Well, to my surprise, what is happening when people report things like that, okay, it's going to be a very crowded area here, then the router is going to tell you, okay, avoid it and go maybe this way. Like nobody is going there right now. And what happens is that usually parts of these areas are quiet neighborhoods. They are places where maybe kids are playing on the street, they are outside, maybe cycling, football, whatever. And the quiet neighborhoods become busy because some software tells them go there, more or less. So the people that don't like this application are the ones that live in the quiet neighborhoods, that have kids and that they want safety. It does happen, and it happens very much because that's the whole point of this application. It will take you on some streets that are not busy so that you can minimize your travel time. Yeah. Of course, overall, I think there are more people that are happy about the application, but still, it's not doing just good. And this is something I found interesting. And if you compare it with Strava, for example, I believe that Strava would do more good, in a sense, in a different sense, not more good, but less bad. Like, I can't see it causing such harm, maybe, unless maybe if somebody is so competitive that maybe they hurt themselves by going very, very fast on some segment or whatever. It's possible. It's good to keep your eye open, like, okay, you use some applications. What could be the harm of inventing an application and having people use it? There are some things, consequences that can happen. And something that relates to our application about the wind routing. If you are going to go with this wind router, it's most likely going to tell you to go in places that have many, many buildings around so that it blocks the wind. This is one result of the application. But one thing that can happen if it's a particularly windy day is that things could fall off from the buildings. I know this is reaching like far away, but more or less my application would tell users to go somewhere where things are likely to fall from the buildings, even though you get less wind. So this is now very, very far-reaching, like nowhere near as problematic as Waze, but still, it's a consequence. In Finland, this happens far less, but in some countries where maybe buildings are made with poor material, even the whole roof can go up. So if it's a particularly bad day, you tell the people go there, and then the roof falls. So of course, very unlikely maybe for it to happen. It needs to be a particularly windy day, a really unhappy situation. But it is a consequence, and they may blame it even on you. It depends where you live, but in some countries these kind of laws allow for all kind of things, like suing people for all whatever reasons. And this is quite problematic for you as well, because when you are going to publish an application somewhere, you can publish it maybe in your hometown or the whole world. And if you're going to publish it in the whole world, different laws apply in different places. So it's not a simple task. You really have to think a little bit about this. I mean, it seems like a very, very innocent application, but it does affect people in some way, and how are you going to be accountable for it? I gave now some very, very extreme examples, but it applies for everything. Addictive games lower kids' grades. So if you make a really, really addictive, cool game, it may mean that they study less and they play your game all the time. I don't know. Nowadays, research says that playing games is very good. I mean, some particular games help with some kind of abilities, like maybe they enhance teamwork, or maybe they enhance problem-solving skills. Pokemon Go is quite a good example of making people go out of the house more, which is a good thing, but then again they go out of the house like this, and that's maybe a bad thing. But overall, I think they did a good job. Of course, we will talk about it more on next week, but yeah. Have you ever thought about these kind of consequences when you make a website or an application, and how your users may be impacted by it existing and it being in reach, like if it's public? Yeah, I mean, it's a fun mental exercise, but sometimes if you really have something questionable, like what some of these applications are doing, then yes, Waze did do this, did make some people's neighborhoods more dangerous, and most likely accidents came because of that, because of the decisions, because how the algorithms work and the platform in general. So this was a very big debate a couple of years ago at the conference on location-based services in Zurich. So they were proposing different strategies for optimizing the roads to avoid accidents, or to avoid safe neighborhoods. I find this line of research quite tricky, quite difficult. I don't know how to handle it myself, because I believe that if you're going to recommend paths that have less accidents, for example, the accidents will just move there, because more people are going to take these paths that are presumably safe, so it also will increase the number of accidents. So of course you can look at historical data, where are the dangerous places, start to avoid them, but that's not going to reduce reckless drivers or the number of cars. And it's very hard to say what is an algorithm that succeeds and what is an algorithm that does not. Many people do simulations, but to do a complicated simulation, a reliable simulation is not the easy thing. So proving that the simulation is a good simulation is also something difficult to do. But yeah, it started, this kind of effect started a different kind of research. Like, instead of shortest path, fastest path, most efficient path, safest path. Actually, my one of my reviewers for my PhD thesis is working on this. He is in San Francisco working in this Microsoft research department there. And he has, I believe, at least 4 articles only on the topic of safest path recommendation. So you can see that this kind of artifact started people to want the need, to have a need for these other systems.